So let me then give you a gist of the idea how the device-independent cryptography works. It's one of those crazy ideas that first time you see it, you say, well, no, it cannot be possibly true. And you know, I've been in this business for a while, and I've been doing this a good part of my life, and I still find it crazy in a very nice way, very puzzling. So, okay, the scenario. Imagine that Alice and Bob were given magic boxes, devices that were produced by a friendly company that is advertising that they have a quantum computer and whatnot. The boxes have a knob that can be set up into two different positions. So Alice has a box, and she can position this knob in a position which I call A0, and another position which I call A1, and the same for Bob. So he has a knob, and he can turn this knob in B0 direction or B1 direction. Then they can press a button, and the outcome will just pop up, +1 or -1. Now, as Alice and Bob take those devices miles away from each other, the devices cannot communicate with each other, but you know, they could have been pre-programmed in some way. So the claim is that if Alice and Bob choose any setting except A1 and B1, the devices will always give the same outcome, and when they choose A1 and B1, the devices will give the opposite outcome. So this is summarized here in this table, that A0 gives the same outcome as B0, B0 gives also the same outcome as A1, and B1 also gives the outcome as A0. So you look at this claim and you say, ooh, that's weird. It cannot be quite right, right? So how come? Certainly you cannot have a value assignment of +1s or -1s to A0, B0, A1 and B1 that satisfies all the four conditions here. Clearly, if A1 is equal to B0, B0 is equal to A0, A0 is equal to B1, so A1, if you think in clear classical Aristotelian logic, tells you that A1 has to be equal to B1. But the claim is that that's not the case, that's just the opposite. So Alice and Bob are puzzled, of course, and think how that can be. Surely if the devices were pre-programmed with so the devices know what to outcome for each round. So you assume that Alice and Bob run those devices many times. So if the devices are pre-programmed by the company that produced them, then of course, you know, there has to be some sort of instructions which tells this device what is the value A0 if Alice is choosing A0, or what is the value of A1 if she's choosing A1 and pressing the button for a given round for this set of conditions to be satisfied. So Alice and Bob look at this table and they conclude, no, it's not going to work. Obviously, that's too good to be true, because then those devices, if we run them, can, if there is a value assignment to every single outcome, so to A0, A1, B0, and B1, then when we run those devices, we will probably see that in 25% cases, one of the conditions is not satisfied. So you see, Alice and Bob are only going to look at the pairs of outcomes. So they will choose, Alice will choose either A0, A1, Bob will choose either B0, B1. They cannot choose both. It has to choose either this one or this one, either this one or this one. So they will somehow probe this criterion, this promise, by checking the pairs in every single run. And because they are going to choose randomly, A0, A1 and B0, B1 will be chosen randomly, then they expect that if there is a pre-programmed scenario, and if indeed there is something that the company did and the devices really know in advance how to respond, so that there are values attributed already to all possible outcomes, in this case they will be able to pick up this inconsistency, and 25% of the runs will be in disagreement with one of these conditions, because clearly all 4 conditions cannot be satisfied. At least one will be wrong, so that should show up. Now let's rewrite this condition in a slightly different way in terms of products. So let me just write it as A0, B0 is equal to 1, all right? So because the outcomes are identical, either +1 or -1. A0, B1 is also equal to +1. Now A1, B0 is equal to 1, and A1, B1 is equal to -1, because the outcomes are always the opposite. Let me just rephrase it in a slightly different way, just to make a connection with something that is related to the origin of the whole field, the whole story of Bell inequalities and the story about the hidden variable. So let's look at this figure of merit. So let me look at S, which I will define as the sum of those terms with a minus prefactor for this term. So let it be A0, B0 plus A0, B1 plus A1, B0 minus A1, B1. So now, of course, the claim from the company is that those magic correlations, so this term S is that the value of S is equal to 4. So that's the claim. But then Alice and Bob look at this expression and they see that they can also rewrite this expression in the following way. A0, B0 plus B1 plus A1, B0 minus B1. And now they think this way. Okay, if it is indeed the case that the values are assigned to A0, B0, A1, B1, then if I look at this term here, I can see that here in brackets I have B0 plus B1 and B0 minus B1. So there are some values assigned to B0 and B1. So clearly one of those terms, if B0 and B1 are identical, so this term is equal to 0. And if they are different, this term is equal to 0. So one of the two terms has to be equal to 0. And the other one is equal to plus minus 2, right? Multiplied by plus minus 1. So that implies clearly that the S, this term here, this quantity here, can be either plus 2 or minus 2. But then Alice and Bob think, well, how will we know? We cannot really, in a single run, measure A0, B0, A1, B1. In any single run, we only can get one value A and one value B. But then they think, okay, but then we can evaluate perhaps the expectation value, the average value of S. Because what we do, we run those devices many, many times. So sometimes we get this term, sometimes we get this term, sometimes we get this terms, but we can see that the average value, right, S, is equal to the average of those terms here. So this they can calculate and evaluate, and they can see that say the absolute of average value, if S can only be plus 2 or minus 2, then the average value is somewhere in between. So somewhere between minus 2 and 2, right? So the absolute of average value of S is certainly smaller than 2. So that has to be the case when you attribute numerical values. If the devices are pre-programmed, if the values are there, then it has to be the case that this figure of merit S is smaller than 2. So the absolute value of S is smaller. The absolute value of the expectation value of S is smaller than 2, right? Now, this looks like a very simple algebra. Well, it is a very simple algebra and a very simple argument. But the consequences will be anything but trivial, as you'll see in a moment. So there is a name to this expression here. It's called Bell inequality. Well, actually, this particular form is known as CHSH inequality. This stands for Clauser, Horn, Shimony, and Holt, four guys who back in 1969 or so figured this out in a completely different connection. But the original idea of having this kind of inequalities come from the Irish physicist John Bell, who I think figured this out in 1964 or so. I'm not so sure about the dates exactly. So let's try to summarize what we have. So the claim from the company is that the correlations will give you 4. Alice and Bob say, you know, if those guys pre-programmed the devices, and if the values of +1, -1 for each setting are pre-programmed and somehow known to the devices, and perhaps known to the programmers and the coders and the company, so there's no way S can go any further than 2. So on this diagram, I'm just going to plot the absolute value of the average of S. So the claim now coming from Alice and Bob is that, okay, anything between 0 and 2, that means that devices are pre-programmed. Devices have values, and there's just no way we can use them to establish any secret key out of the outcomes. So this range for correlations for S, let's call it classical, and also the Bell range. So that's the first part of the story. The thing is that if Alice and Bob get anything above the 2, it may not be 4, as the claim is, but anything above the 2, they will be a bit puzzled, right? Because that means that the original assumption that devices are pre-programmed and somehow someone knows about the values of A0 and A1 and B0 and B1 is not valid anymore. And that could be an opportunity to establish something that is secret. So let's see how it works.